Example 1, Part A. We are going to compose f and g and find the value at 1. So f composed with g of 1 would equal f of g of 1. Whoops. So I'm going to start with g of 1, find the value of that, and then plug that into f. So g of 1 means I'm going to take this function g and I'm going to plug 1 wherever there was an x. So that will give me the absolute value of 1 minus 3, which is equal to the absolute value of negative 2, which is 2. So now I'm going to take 2 and plug it into the function f of x. So f of g of 1, well, since g of 1 is 2, I can replace g of 1 with 2, and f of 2 is going to equal 2 squared over 2 minus 6, which would equal 4 over negative 4, which is equal to negative 1. So f of g of 1 is equal to negative 1. You can also compose a function with itself. So f of negative 2 means I'm going to find the value of the function f at negative 2, and then whatever I get, I'm going to plug back into the function. So f of negative 2 is equal to negative 2 squared over negative 2 minus 6, which is equal to 4 over negative 8, or negative 1/2. So now I'm going to find f of negative 1/2, because I'm taking what I got and plugging it back into itself. So that would be negative 1/2 squared over negative 1/2 minus 6. Well, that's equal to 1/4 over negative 6.5, which is 1/4 over, and if I change that to an improper fraction, that would be negative 13 over 2. So now if I change this to a division problem, that would be 1/4 divided by negative 13 over 2, which is equal to 1/4 times negative 2 over 13. So that cancels to negative 1, and that cancels to 2, and my final answer would be negative 1 over 26. Finally, I'm going to compose g of g at the value negative 1. So I'm going to find g of negative 1 first. And that's equal to the absolute value of negative 1 minus 3, which is the absolute value of negative 4, which is 4. So now I'm going to find g of 4, which is equal to the absolute value of 4 minus 3, which is the absolute value of 1, which is 1.